Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 931, minimum falling path sum. So it's a medium level problem, and we will first check out the problem statement, then we'll check out the approach which you're going to use, and towards the end we'll see the code as well. So starting with the problem statement is given that we will get a n cross n array of integers matrix, and we have to return the minimum sum of any falling path through matrix. Okay, a falling path starts at any element in first row and chooses the element in the next row that is either directly below or diagonally left or right. Specifically, the next element from position row column will be row plus 1 column minus 1 row plus 1 column or row plus 1 column plus 1. Okay, so what we have to do basically is to find a path to reach the last array or the last row in the matrix with the smallest sum possible. Okay, so the straight uh, you know the easiest solution to this problem will be the DP solution using a dynamic programming solution, and that's exactly what we are going to use. So let's check out the approach which we'll be using. Okay, so this is the approach which we'll be using, and before starting the explanation, let's check out what we have, like what is given in the problem statement. Okay, so these were the possible paths you can take from any particular point. So suppose you are at this cell at the moment, which is at I comma j. You can go to these three locations. Okay, you can go diagonal left, below, or diagonal right. So if you are, for example, if you are here, you can have these three locations. Okay, and what I will be doing is I will I'll just change the notation. So instead of going to the next row, I'll check for the previous rows. Okay, so if you say over here, we are using the other way around, like we are not going from bottom to top, we're going from top to bottom. Okay, so these are a few notations which we'll be using. So for example, to define a diagonal left, this will be the notation I minus 1. So basically if you are here, I minus 1 is 0 and j minus 1, which will be this one. Okay, similarly right one will be I minus 1 j plus 1, and below will be I minus 1 and j. Okay, so these will be the notations which we'll be using, and this is the formula which we will use to compute the minimum uh, the minimum sum to reach any of the nodes. For example, if I want to reach this node, it will be 6 plus minimum of these two values. Okay, because these are the two possible paths, that's why. So let's do a dry run and let's see. For example, so what I'll do, I'll initialize my DP array with zeros, and I'll copy this element, like this first row, so that we have our base case ready with us. Okay, now from the second row we will iterate through each element one by one. Okay, so 6 5 4 7 8 9 one by one, and we'll check each possible path. For example, from 6 I can either go to 2 and 1. The minimum is 1, so we will add 1 in it, so it will be 6 plus 1 equals to 7. Okay, similarly for 5 we have 2 1 and 3. Okay, so we will use 1 because it is a minimum, so it will be 5 plus 1, the value is 6 now, the value over here is 7 now. Okay, for 4 we have 1 and 3, the lowest is 1, so we will do 4 plus 1, which is 5 now. Okay, now we are at the last row. For 7, these two are the possible paths, so the minimum among these is 6, so we'll do 7 plus 6, which will be 13. For 8, all the options are open, we can check left, above and right. So the lowest among this is 5, so 8 plus 5 is 13. Okay, and for 9 we have 6 plus 5, sorry, 6 or 5, so lower among that is 5, so it will be 14 now. So if you see, we have two possible paths. First one is this one. Okay, and the second one is starting from 1 going through 4 and then 8, this one. Okay, So we got these two parts, and if you check out the example in the problem statement, this is the exact solution which we were looking at. So let's check out the code for the same as well. So over here, what we are doing is we have defined a DP. DP, it will be a n cross n array of the same size of matrix, and we have initialized everything with 0 for now. Okay. Next is, as I said, I'll be copying the first row of the matrix to have the base case ready with us. Okay. Now from the first row, we have started the iteration, and we are going one by one through all the elements. Okay. Now we wanted to get the minimum sum, right? So for that, what I'm doing, I am taking, or what we can do, we can just simply remove this because we are not, we won't be using this now. We can directly take the, you know, the minimum of the three possible values. So for below function, what I have done, I have initialized with float infinity, so that if it is not possible to go to this element, we will just take the infinity, and this won't hamper with the results. So what we are doing, we are checking if I minus 1 is greater than 0, then we are going to the element and we are considering that element. For left also, we are checking the same condition and we are considering if the condition is satisfied. For right also, we are doing the exact same thing. So after these points, we will have all the elements which we can refer to. At last, what we are doing, as I said, we will be adding the minimum of all the possible paths with the current element. So for example, we had 6, right? So 6 plus 1 will be the solution, right? So we will storing 7 in the DP of ij, and at the end we will just simply return the minimum from the last row, and that will be the solution for the problem. Let's check out the test cases. So the test cases got clear. Let's submit it for further evaluation now. It is taking some time. Yeah, so as you can see, the solution got accepted, and say like we have performed well. Okay, so yeah, this was the solution, guys. Thanks again for watching out the video. Stay tuned to the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.